Hello, students. So, good morning, all of you. So, in the previous classes, we already derived the formula to calculate the electric field for a uniformly charged infinite plane sheet. We actually did that and derived the formula as E is equal to sigma by 2 epsilon naught. This is the electric field formula. So what is sigma? Sigma is the surface charge density and epsilon naught is the permittivity of vacuum, and you know this value. And even when you are given to find electric field for a infinitely plane sheet which is uniformly charged, you can actually use this formula. So you can see that this formula is independent of R, provided that the sheet should be infinite. Provided that the sheet should be infinite. That means it should be infinitely large. So E is equal to sigma upon 2 epsilon naught. You can see that the RHS doesn't contain R. The right hand side of this equation, you can actually observe there is no R in this formula. There is no R. That means electric field for this part is independent of R. Since it is not depending upon R, it is independent of R. So that means if it is an infinite sheet, then B may be here, P may be here, P may be here, or here, or here, or here. See, the distance is increasing or the distance is changing. But electric, it should be infinite. Okay, it should be infinite. So electric field at this point is the same as this point, is the same as this point, is the same as this point, and electric field at this point is the same as this point, is the same as this point, provided that, and the only condition implies that it should be infinitely large. So this is what all about our electric field for a plane infinite sheet. So you can actually see from here that it is independent of R. You can write that electric field, it is a node here. In this case only, okay, it is, or here E is, electric field E is independent of R. Okay, it doesn't depend upon the distance. Even if you increase the distance, even if you keep this thing at this place, it doesn't change the value of electric field. Here the value of electric field is the same as at this point. Okay, but this is not possible. We cannot have an infinite stretch of plane sheet. So what we consider, that we consider this as a large thing. Okay, a very large thing, and the point under consideration is located very close to this infinite large sheet or this sheet. The point under consideration should be very close to this sheet, since as which will overshadow the size of the sheet, will overshadow that distance. So you need to consider these things. If you do not imagine this large sheet, you need to consider a sheet that is large enough that we can ignore this distance. We can ignore the distance between these points. Okay. So here we can see that E is independent of R, and also we can see that the direction of electric field. What is the direction of electric field? It depends upon sigma. Electric field, the direction of electric field here depends upon sigma. So if sigma is positive, that means if it is uniformly positively charged, then electric field is going this way. Okay, if it is totally charged like this, okay, let me write a plus in the middle only, and you should just assume that it is uniformly distributed with surface charge density sigma. So if it is uniformly charged like this, then electric field are going to be like this, going outward. Okay, so the direction of E depends upon sigma. Depends upon sigma. If subpoint, the subpoint of this point, if sigma is positive, then field lines are outward. Then field lines are outward. Okay. Now, in this case and another case, you see that this is an infinitely large plane sheet which is uniformly charged. You can see that it is minus in negatively charged. So the electric field should be coming like this. Should be coming like this. Okay. We can draw such things. Now, another subpoint, if sigma is negative or the charges are negative, then field is inverse. Then field is inverse. Okay, you can note these points. You can note these points because these are important points. After this, we are going to do an example, and after that, you will be understanding it better. So, for this purpose, I am going to rub it off. Okay, this is quite an example. You can solve this yourself also. So, if the question is if there are two parallel infinite sheets, both, we can just not include the bracket sheet, both charged positively with surface charge density, sigma. Then, okay, let me see the questions once again. Okay, just hold a bit. Then, determine the electric field at points to the left of the sheets. Okay, charge density, both charged positively with charge density sigma 1, sigma 2. Let it be. One is charged with sigma 1 and another is charged with sigma 2. Then we are going to find electric field at certain positions. Electric field at, okay, don't include these points now. I am going to draw you a diagram and then you can actually understand these things. So there are two parallel infinite sheet. This is one infinite sheet. This is one infinite sheet. Consider these as infinite sheet. It is charged with sigma 1. It is charged with sigma 2. Both are positive. So we need to find electric field at one left of these sheets. We are going to find electric field at these points. Second, middle of these sheets. We are going to find electric field as these points. And third, right of the sheets. Okay, we are going to find electric field at these points. If it is charged with sigma 1, then let the electric field produced by this sheet be E1 and let the electric field produced by this sheet be E2. So now let us write the answers. Okay. Answers. Before going to that answer, we are just writing some introduction. Let E1, this is sheet 1, This is sheet 2. Okay. Let E1 be the electric field and both are in vacuum. Both are hanging in vacuum. Let E1 be electric field of sheet 1. Okay. So what is E1? What is the value of E1? Equal to sigma by 2 epsilon naught from formula. Okay. You can see that from formula. And for similarly for sheet 2, it is E2 equal to sigma 2 by 2 epsilon naught. Okay. This is E1 and this is E2. So you can actually find the formula for electric field as I have instructed you earlier that E is equal to sigma by 2 epsilon naught. So electric field of this sheet is E1 equal to sigma 1 by 2 epsilon naught, and for this sheet it is sigma 2 by 2 epsilon naught. So since both are positively charged, you can actually find that electric field direction for sigma 1 it is like this. Okay, the direction of electric field E1. Similarly, or likewise, the electric field direction of this to the right of first sheet is like this. Now considering sheet 2, since it is also positively charged, to the right it is like this. They go outwards, and to the left it is like this. Okay, E1 and it is E2. To the left of the sheets, okay, for answer 1, to the left of the sheets, you can see that to the left at these points E1 and E2 have the same direction. E1 and E2 have the same direction. So they can be added algebraically. You know, if two vectors are going in the same direction, you can actually add them algebraically. So for left of this sheet, you say let E left the net. Okay, that is E1 plus E2. We are going only to calculate the magnitude, and if you are being asked to find the direction, you can actually say it is to the left. So you just write the formula sigma by 2 epsilon naught plus sigma 2 by 2 epsilon naught. When you take 1 by 2 epsilon naught common, it is sigma 1 plus sigma 2. It is sigma 1 plus sigma 2, or E left is equal to sigma 1 plus sigma 2 by 2 epsilon naught. Okay, this is your formula, or this is your required formula. Now for middle of this sheet, see E1 is to this side and E2 is to this side. Okay, they are opposite to each other. So you do not know that if E1 is greater or E2 is greater, and you know that for a vector, two vectors can be subtracted if they are opposite to each other. They can be actually subtracted algebraically. So, but you don't know that sigma 1 is greater or sigma 2 is greater, and for this situation, if it is not specified sigma 1 is greater or sigma 2 is greater, you cannot actually say that E1 is greater or E2 is greater. So you can actually take the mode. Okay, you can actually take the mode if it is not specified. So E middle is equal to sigma 1 by 2 epsilon naught minus sigma 1 by sigma 2 by 2 epsilon naught. And why is this so? And you can take the mode. Okay, you can take the mode because you don't know which one is greater, which one is smaller. Okay, so you don't know it properly, and since they are opposite to each other, you have to subtract them. So sigma 1 minus sigma 2, you take the mode and divide it by 2 epsilon naught, and this is the value of electric field. This is the value of electric field. Okay, now to the E right. Okay, you are finding the net electric field to the right. What should be it is? See, to the right, it is E1 is facing this direction and E2 is facing also right direction. E1 is facing right and also E2 is aligned right. So they add up. they add up algebraically as they are along the same direction. So you can actually see E1 plus E2 sigma 1 by 2 epsilon naught plus sigma 2 by 2 epsilon naught. So sigma 1 plus sigma 2 by 2 epsilon naught. This is your required formula. This is your required formula. I hope it is visible to you at this point. Yes, it is actually visible. So sigma 1 plus sigma 2. So we can write the formulas here. For 1 it is sigma 1 plus sigma 2 by 2 epsilon naught. Now for 2 it is sigma 1 minus sigma 2 by 2 epsilon naught. For 3 it is sigma 1 plus sigma 2 by 2 epsilon naught. For this case it is to the left. The direction of the net electric field is to the left. For this case it is to the right. The direction of the net electric field is to the right. And for this case, we only can specify the direction only if we know that sigma 1 which is greater, sigma 1 or sigma 2. If sigma 1 is greater, then the net electric field is to the right, and if it is smaller, then the net electric field is to the left. Okay, so I think you have understood the concept. Now, if sigma 1 is equal to sigma 2, I think this portion is visible. Okay, this is visible. This is right. Okay, now if sigma 1 is equal to sigma 2, if sigma 1 is equal to sigma 2, if, then how can you modify these answers? That is, 1 becomes, if sigma 1 is equal to sigma 2 and actually write it as sigma, then what should be the electric field E left should be, so sigma plus sigma, that is 2 sigma divided by 2 epsilon naught. So 2 to get cancelled, sigma by epsilon naught. Okay, sigma by epsilon naught, if this case is given. Now for second, if sigma 1 equal to sigma 2 is equal to sigma, then sigma minus sigma is equal to 0. Then E mid is equal to 0. So I hope that you understand this concept. Now if the same case, see, the first one and say third one are the same cases, so you can actually write like this: E right is equal to sigma by epsilon naught. So these are your answers. So you can do such things in a more proper manner if you understand these things, and these are very frequent questions. These infinitely charged parallel plates are very frequent question. You are going to study these in capacitors also, provided that one of the plates of a capacitor is positively charged and the other is negatively charged. Okay, the other plate is negatively charged and the first plate is positively charged in a capacitor. Once we reach capacitor, we are going to study it in details. Okay, so I hope that you understand this concept, and I can actually set you a homework. I can actually set you a homework. For you. You can do actually a homework, and you will be understanding this concept thoroughly. Okay. Now, if 1 is sigma 1, let the other be negative. Okay. If 1 is charged with sigma 1, that is positive charge, the other is charged with minus sigma 2. It is positive, this plate is positive and this plate is negative. This is your homework. You need to find the electric field, or this is sheet 1, sheet 2, E1, E2. You need to find electric fields to the left of the sheets, to the middle of the sheets, and in the right of the sheets. Okay, this is your homework. If there are two parallel infinite sheets, both charged positively, both are not charged positively, I can say both charged uniformly. This is what your homework is all about. You have to find if there are two parallel infinite sheets, both charged uniformly with surface charge density sigma 1 and minus sigma 2, that is, one is positively charged and the other is negatively charged, you need to find electric field at the left of the sheets, at the middle of the sheets, and to the right of the sheets. Okay, this is your homework is all about. So we can confirm this question in the next lecture. So up until then, just keep practicing, and if there are any doubts, you can ask in the comments, and I will make sure I will make a good response to your questions, and I will be giving other details how you can get connected with me in the description box. And like our videos, subscribe to our channel, support us, and thank you. See ya.